Good day everyone, my name is Nazarova Elena. I'm glad to introduce you to our research, CobotAR, interaction with robots using omnidirectionally projected image and DNN-based gesture recognition. In the last few years, many technological solutions supported the development of augmented reality, virtual reality, and mixed reality interfaces for multi-user collaboration. Based on the number of papers indexed by the Scopus database between 1994 and 2020, the interest in AR, VR, and MR technologies is rapidly growing. However, these types of technologies in robotics require the use of extra wearable or healthy devices for the user, which can be extremely inconvenient. For example, wear devices limiting the user's work area, or glasses for AR have limited field of view. The slide shows a very small part that is relevant to the CobotAR. All of them certainly have their advantages, but they also have their disadvantages. The main disadvantage of all these three projects is that they have an extra wearable or healthy device for the user. And as I said, in some cases, this is very inconvenient. For example, the work ROMA, interactive fabrication with augmented reality, and a robotic 3D printer, where a designer creates a new model by a 3D printing robotic arm. Our team analyzed and highlighted the most important advantages such as, first of all, this is fast, precise, and hands-on modeling experience. Also, ROMA lets users integrate real-world constraints into a design rapidly. But the current ROMA implementation is concentrated by the use of an industrial-grade robotic arm. To ensure the safety of the designer, they internally limited the robotic arm's movement speed. Thus, the system quite slow. Further, native robotics. One of their projects is OmniFit. It is a hyper-realistic AR system for the whole series universal robots. All these models are interactive and customizable already in the app. Therefore, it is very easy for customers to use. Customers can show cases for their solutions to anyone and everywhere. But this system integrates via phone or tablet. Therefore, OmniFit has limited working area. And the last system for analysis is AAR, augmenting a wearable augmented reality display with an activated head-mounted projector. They introduce the system by combining a wearable AR display with a wearable spatial augmented reality projector. This technology doesn't have the problem of limited the working area, since the projected environment is integrated in the real world and the user can interact with it. Also, other people can also take part, which is very good for collaboration in the work. We present CobotAR, a new AR technology to achieve the human-robot interaction by gesture recognition based on DNN without an extra wearable device for the user. Let me show the video with system overview to achieve better understanding how system works. To understand, then the user pressed the projected button, and then the robot needs to start moving. We use the DNN-based gesture recognition model, which implemented on the basis of MediaPipe framework. It provides high-fidelity tracking of the hand by employing machine learning to infer 21K point of human hand just for a single captured frame. To conduct an experiment, our team designed, printed using a 3D printer, and assembled a marker holder on the end effector of the UR3 robot before the experiment. Moreover, we fixed a 150 by 150 mm square printed on the white paper on the table. There the robots allocated. You can see it in the experimental setup figure. Participants were asked to repeat this trajectory, manipulating by the teach pendant, the gamepad, and the novel CobotAR system to evaluate the controllability of the robot, using these three different interfaces. 12 participants conducted the experiment. None of them reported any problem and difficulties in CobotAR functionality. The use of these three systems for the experiment was fundamentally different. Therefore, before starting the experiment, the participants performed a training session. The interface to control the robot through the teach pendant is represented in the left figure. Changing position of the robot using gamepad represented in the center figure. And finally, the graphic user interface to control the universal robot through the CobotAR system is represented in the right figure. During the experiment, our team collected such parameters as time, which participants spent to draw the square using each interface. You can see the results on the time performance comparison graphic. Considering average values, the fastest interface is the wireless gamepad, second the CobotAR system, and third the teach pendant. And we compared the average error between the printed square and the trajectory drawn by the users using each of the interface. You can see the results on an average error comparison graphic. Participants were on average 1.1 cm from the right path using the teach pendant interface. Using the gamepad, the average error was 2.5 cm, and using CobotAR, it was 5.1 cm. After the experiment, each user has asked to take a survey to rate the Nazarova and post-experience questionnaire for feedbacks. Using CobotAR, participants achieved the best results at Nazarova ratings, such as mental demand, physical demand, temporal demand, effort, and frustration. Besides, the approach demonstrated accuracy and time performance comparable to other interfaces. The CobotAR technology could be potentially used in various applications such as interactive education programs in entertainment, industrial human-robot collaborative scenarios. We introduced also CobotAR scheme, reflecting the robot's state and its current task. CobotAR Zoom, robot repairing support service based on online teleconferencing. We introduced a novel human interaction approach based on the graphical interface projected directly on the robot's links and DNN-based gesture recognition. The developed approach doesn't require an application of any wearable devices for the user. Using CobotAR, participants achieved the best results at Nazarova ratings, such as mental demand, physical demand, temporal demand, effort, and frustration. This suggests that the CobotAR is suitable for robot operation, especially for demonstration and education. The mental demand of the CobotAR system is twice less than the gamepad, and by 16% less than teach pendant. For the future work we consider, first of all, improving the gesture recognition algorithm. Secondly, decreasing system delay to improve the CobotAR time performance. And develop a virtual scene with 2 digital twins in Unity engine. That's all from my side. Thank you for your attention.